All right, so continuing on with our revision, and you don't really get to see me in this one, but that's okay because we're just doing shapes. So here we've got two different sets of lines, and what is the difference between them? Well, in maths, there's just lots of differences between them. But what I'm looking for essentially is that these lines are what they call parallel lines. And you know lines are parallel and they've got these little arrow thingies between them. And what it means when lines are parallel is that they can continue on like for kilometres and kilometres and kilometres, and they'll never touch. Whereas these lines, see, that aren't parallel, like if they keep extending on the way they're going, eventually they're going to intersect. And so parallel lines are the bases of a lot of our shapes. So in a square, it's a pretty bad square, and in a rectangle, and in a, I think that's a trapezium, okay? Essentially, so the properties of any of these shapes, which are known as parallelograms, is that the opposite sides of any of these shapes are always parallel. They'll never meet. Okay? So, in a square, every side is equal. So, in a square, whatever this side is, if it's 2 centimeters long, every side is 2 centimeters. That's a square. And so we're working out the area of a square. Side times side, so length times width, which is 2 times 2, or in the case of a square, 2 squared. In a rectangle, so just like a square, these lines are parallel and these lines are parallel. And the opposite sides are always equal. So if this side is 4 centimeters, this side must be 4 centimeters. And if this side is 2 centimeters, this side must be 2 centimeters. So area of a rectangle, we're working out same as a square. So we've got the length times the height, which gives us 8 centimeters squared. Now, in a rectangle and in a square, all our angles are 90 degrees. And remember, we show that a 90 degrees is by doing it like that. And a 90-degree angle is also known as a right angle. Now, a right angle doesn't necessarily mean it's on the right. See, this one's up here on the left. It's a right angle. This is a right angle. This would be a right angled triangle. This is 90 degrees. Don't know why it's called a right angle. 90 degrees is a right angled triangle. But in any four-sided shape, even this one here, all the angles inside the shape add up to 360 degrees. So 90 plus 90 plus 90 plus 90, 360. 90 plus 90, 360. So what that means, if inside a four-sided shape, you know that the angles are always 90 degrees, you know it's always 360. But say in this one here, right? This side's always the same as that side, same as that side. So if you knew this angle here, it would be the same as this angle here. And if you knew this angle here, it would be the same as this angle here. And they would all add up to 360. All right, so that covers our four-sided shapes. Now, in our triangles, now we use the arrows to show that lines are parallel. in a triangle, if we're showing that sides are equal, and we do a little thing like that. So parallel lines show they're parallel, it's an arrow. Okay, so different to a triangle, you see these little thingies? It means that they are all the same. So that side was 3 centimeters, that side is 3 centimeters, that side is 3 centimeters. And because these are all the same, all these angles are the same. Now you remember that in our squares, they always added up to 360, all the angles inside a square. And we can divide a square in two to make 2 triangles. So if all the angles inside a square make 360, and we've divided the square in 2 to make 2 triangles, we know that all the angles in a triangle must always equal 180 degrees. So if all the angles in a triangle always equal 180 degrees, and these 3 angles are all equal, we know that 180 divided by 3 equals 60 degrees. So an equilateral triangle, all the angles are always 60 degrees. We'll leave that there.